Okay, so in this piece of material, we're going to focus in on the idea of distribution. And we've talked about distribution as kind of like the shape of the data. And when we're referring to that, we're talking about like how does it appear in a histogram. Okay, so there's two common distributions that happen. So one of them, or there's common distribution shapes that happen. One of them is what's called a uniform distribution. And if you have a uniform distribution, the histogram for this is going to look kind of like a fence where like somebody has come along and put boards up that are almost like the same length but are slightly different, but not a whole lot of difference, right? So if you look at the tops of each of these fences are about the same size. Okay, so like if you kind of think about this, if I were to kind of like grab the tops of these, it kind of like feels like it's a line going across the top. So uniform distribution means that it's like there's an equal probability that if I selected somebody from at random, I'd have an equal, almost an equal probability of selecting somebody from each of the classes that make up the histogram. So uniform kind of looks maybe a little bumpy, but it's still fairly flat across the top. So that'll get you a uniform distribution. The second type of distribution that we'll see is one that is a bell-shaped. Okay, so bell-shaped distribution. And bell-shaped is like very common. There are several different distributions that have a bell shape. So when you have a bell-shaped distribution, usually in the center of the distribution or at some point along the distribution, you have a pretty high point. And it stays pretty high in the middle for quite some time. And then all of a sudden it'll like make a drop. And you'll see a pretty quick drop along one side and then see a pretty steady drop along the other side. And if you were to kind of make like a curve to fit the data here, it kind of looks like it goes up, comes back down, and we call that a bell-shaped curve. So it has kind of like this big center between like here and here, lots of data points in the middle, but then like once we get out into the tails, a lot fewer, right? So the frequency is high in the middle and smaller in the tails. Now, this is going to bring us to a topic that's related to this called skewness. Okay, so this particular curve, the high point right there is in the center of the range of data. Okay, so like the tallest part of this is in the center of the range. So this is what we would call a symmetric bell-shaped curve. It has no skew. Okay, so it's the big hump is in the middle and the tails are about equal size in both directions. Okay, so then we get two other types of skewness. We get a left skew, sometimes called a negative skew, and we get a right skew. Sometimes called a positive skew. Okay, so when you have a left skew, the histogram kind of looks like this. It kind of has the high point is actually off to the right, which is a little counterintuitive. and then it makes its way down. But if you look, the histogram kind of, if you kind of follow out the curve here, it has a bell shape still, but it has a long tail to the left. So you want to pay attention to where the tail is. Okay, so here you have a long tail to the left. If you have a left skewed piece of data, that's what's going on. Okay, so the center will be bunched up on the right hand side, and you'll have like a long tail to the left. So a right skew histogram is almost exactly the opposite. The high point will be on the left hand side, and then you'll get like a long tail off to the right. So again, it's still a bell-shaped distribution. It's just not centered in the middle, right? It's got a little tail over here, but a long tail over to the right. So this is a right skew because it has a right tail, and this is a left skew because it has a left tail. Okay, so it's a little bit counterintuitive because I think sometimes people want to say, where is the hump? And it's not where the hump is, okay? It's where the tail is. So the skewness is labeled by where the tail is. Left tail, left skew, right tail, right skew. All right, so this gives me a way to talk about the distribution of data. Uniform is kind of like straight across, maybe a little bumpy on the top, but straight across. Bell-shaped can be either left skewed, right skewed, or symmetric, but it kind of has a big hump somewhere and a little tails somewhere. If the tails are equal on both sides, then we say it's symmetric. If the tail is on the left-hand side, we say that it is left skewed. And if the tail is on the right-hand side, we say that it is right skewed. All right, so thank you.